right, it's 7:30 my time here in the Netherlands. My name is Simon de Haan. I am the CTO and co-founder of TurniO. Thanks for joining me. Thank you for this opportunity also to talk about the launch of the WHO's global response to the COVID-19 pandemic using WhatsApp. And so I'll be telling the story of how that went and the tools we used and the things we learned and things that were successful and the things that weren't. So here we go. TurniO is a software as a service company. It's spun out of a nonprofit in South Africa called Prekot.org. We have a decade-long history of using SMS and similar texting platforms for social good initiatives in areas such as health and education, employment, and civic engagement. And since 2017, we've been working with specifically WhatsApp on Turn, and with the intention to build a tool for teams to have personal guided conversations that improve lives at scale. So this is a software as a service company. The tool itself runs in your browser. And this is the tool that was used to launch WHO's global WhatsApp response to the COVID-19 pandemic. So what that practically means is that we help social impact organizations and teams scale their work while not being completely overwhelmed. And the strategy here is quite simple. We connect teams to their audiences over WhatsApp, and then we help prioritize the key conversations that need that need most urgent attention, and we help guide those conversations towards very specific outcomes. And then we track whether or not that's actually happening. And so an example of this is the South African National Department of Health's Maternal Health Program, which we helped launch as part of a WhatsApp pilot in 2017. This is where we started our work with WhatsApp. And the Department of Health needed a way to be in regular contact with pregnant women, needing to be able to triage questions coming in, give guidance according to the national health policies, and keep track of the progress being made with regards to clinic visits, inoculations, information relating to nutrition, and at a later stage also early childhood development. And so this was 2017 where we launched this, and this was a world's first. The system is still running. It's over 1 million subscribers at the moment in South Africa. Now, fast forward to 2020 and the global COVID-19 pandemic. So we built on those experiences that the services we launched in 2017 and between 2017 and 2020. And so building on those experiences, we launched COVID Connect in South Africa, which was the world's first COVID-19 hotline on the WhatsApp Business API. This service reached 500,000 unique users before the official launch and has since grown to 8 million subscribers. And this was launched for the South African Department of Health, and Prekot.org is the parent organization that we as TurniO spun out of. So that was actually the first launch that predates the WHO work. And so we had previous working relationship, a long-standing relationship with the WHO on various initiatives, and things came together with Mark Zuckerberg meeting the Director General of the WHO. And the proposal was to launch a service over WhatsApp in response to the COVID-19 pandemic. And we were asked to launch this as soon as possible, preferably within a week. What made this really interesting was that it was the world's first launch of this size. No one had ever run a WhatsApp Business API installation capable of the kinds of volumes that were expected. And what made it really pressing was that in the era of COVID-19, misinformation can actually spread faster than the virus itself. And so you really need a platform that is immediate and private and trusted, that people can consult to find out what's the latest information, what's the latest guidance. And so WhatsApp was the perfect tool to do that, because a lot of the understanding of the virus and how to guard yourself against it was still developing, and actually still is. And so being able to expose that information over WhatsApp was really critical to significant amounts of people. Now I know many people in the US do not use WhatsApp so much, but in the rest of the world, WhatsApp is really, the usage is so widespread that in many ways it's almost a global telco. So what the service actually looks like is really quite simple. And if you do have WhatsApp, you can interact with it right now. So you can text hi to the number, but it's probably easier just to scan the QR code with your phone or with the built-in QR code reader in WhatsApp itself. So one of the features on the service is that you can get live updated case numbers per country. It automatically detects what country you're from and then consults the John Hopkins services to find out what are the case numbers for the area that you're in. It has news information relating to COVID-19. And these are up-to-date real-time pieces of information, the latest guidances from the WHO on how to protect yourself. As critical is also exposure to guidance around combating misinformation. And so there's a sample fact on the screen there that says drinking alcohol does not protect you against COVID-19 and can be dangerous. Now there's so many of these pieces of misinformation being spread on various social media, and being able to offer this service on WhatsApp is really quite incredible. And so this service launched on the 20th of March. So launch day looked like this. We had multiple clusters. This is the graph of messages per second on one cluster. The initial announcement was done by the Director General, Dr. Tedros, who's the Director General of the WHO. There was a live press briefing out of Geneva where a whole bunch of matters were being discussed, and one of the things was this WhatsApp service. And you can see an immediate spike of messages per second going to just over 400 messages a second for this one cluster. A couple of hours later, Mark Zuckerberg put it on his Facebook page, which apparently he has a lot of followers on there. And the request per second jumped to, I think it was just around 660 messages a second. As you can see, if you can see in the presentation, we used a bit.ly link to help route people to various clusters to balance the load. And I'll talk a little bit more about that later. So this is what launch day looked like. It was on the 20th of March. And it was really quite incredible because we've never seen a service scale this fast globally before. And we've done quite a few, certainly national launches or regional launches, but this was the first global. And 10 million people used the service in just over 48 hours. And it was able to provide accurate information around COVID, around what you can do to protect yourself. It was available to everyone. It stayed up. We didn't suffer any downtime during any of this dramatic growth. And that's something we're incredibly proud of. And Phoenix and Elixir, the stack and the technologies we used really contributed in making that possible. So this is the timeline of how quickly this all actually happened. The South African work, the COVID-19 Connect hotline, which was the first one, the work started on that. We got approval on the 9th of March. And that eventually launched officially on the 18th of March, but there was a soft launch earlier around the 15th, which I'll talk a little bit later about the idea of soft launches there. Once we had approval for the COVID-19 Connect service, and that was showing promise and was showing traction, the work on the WHO service started. And that was on the 11th of March. Now, the WHO service was a completely dedicated set of clusters, completely isolated environments. And that was also the first time we ran this infrastructure on Amazon Web Services. And so we had to do a bunch of work pretty much overnight to make sure that all of our infrastructure provisioning tools were able to provision on AWS. And so the infrastructure was ready by the 17th of March. The soft launch was the 18th of March, and the public launch was on the 20th of March. And so for a global response, it was really incredible to see the tools work as well as they did in such a short amount of time, and see everyone pull together. So yeah, it's roughly about a week for each, I think, just under a week for each, to go from approval straight to infrastructure ready, copy ready, all of the content, all of the integrations with various APIs and whatnot, everything done, load tested. It was just under a week. So I'd like to talk now a little bit about the stack that powers this. The infrastructure is actually, it's almost, well, I guess nowadays you could call this boring. It still blows my mind how all of this stuff works, but it's Kubernetes on Amazon's web services. So that's their elastic Kubernetes setup. And it was provisioned with Terraform. We use Postgres 9.6, Elasticsearch, Factory 0.8. And I think those are all fairly, well, somewhat older versions of the software of stacks. There's newer releases been since. The only really latest versions we're running is Elixir itself on 1.10.4 and OTP 22. So these are really these pieces of technology really form the bedrock of this installation. We love Postgres as a database. It's extremely solid and a very reliable workhorse. Yeah, so I'll talk a little bit more about the stack itself. The Phoenix, it's just a Phoenix app, really, most of it with a standalone React front end that's deployed via Netlify. We use GraphQL to have the front end communicate with the back end. And on the back end, we use Absinthe for that and the React Apollo framework. We make heavy use of GraphQL subscriptions, which allow us to push updates from the server live to the front end over Phoenix channels, which is a pattern that's scaled extremely well for us. And it's been quite incredible to see. We use Data Loader on the back end to connect to the database and allow Absinthe to get the data that it needs. Arc to handle all the media. For Amazon Web Services, that's obviously S3. Quantum and Highlander is an important combination for us. Highlander is actually quite recent as a package. Quantum is for those that don't know, Quantum is you can think of it like cron for Elixir applications. It allows you to run jobs on a schedule. Now, if you're auto-scaling things and you have multiple instances of your application running, if you're not careful, you'll issue a denial of service attack on your own stack simply because Quantum runs on every single instance. Highlander ensures that there's only one Quantum process running across your cluster, and it really helps, speaking from experience. Another library that's important to us is X-rated. It allows us to rate limit things on all of our endpoints. Being able to control your inbound and outbound traffic and have the right tooling for that and then not worry about it anymore is really great. We use Factory Worker X to talk to Factory. It allows you to define your jobs and your background processes that you would like to run. The stack itself looks pretty predictable. There's the load balancer, which in this case is Amazon provisioned. We have a number of Phoenix applications, which is essentially the Turn stack. Then there's a fair amount of Factory job workers. Again, Factory is the background job worker. Both the Phoenix app and the Factory workers are auto-scaled within limits based on CPU thresholds. And that's worked very well. And they're also automatically clustered with libcluster using the Kubernetes strategy. This stack was replicated in multiple zones around the world to ensure load balancing. Yeah, WhatsApp conversations can be started with a URL. As I said earlier, we used a bit.ly link to round robin between different clusters. So we had one bit.ly link, anyone clicked on it, we could then redirect to one of multiple clusters around the world to serve that traffic. And that worked very well. For those not familiar with the WhatsApp Business API, the WhatsApp Business API is largely an on-premise installation. And so you need to run a bunch of containers on your own infrastructure. To deal with the traffic on each of these clusters, we were fully maxing out to maximum capacity, which was 32 shards per cluster to deal with the traffic. So now I'd like to go to the things that worked. I'm seeing a couple of questions come in. I'll leave those to the end so we can address them all together there. So the things that worked. Clustering, the ease of clustering Beam nodes is really magical. As a team, we come from a Python background, and TurniO is our team's first production Elixir environment, actually. Some of the things that were hard problems in Python just don't really exist. And so working with Elixir and seeing it automatically form a cluster was really amazing, because all of a sudden there's like this whole class of problems that you didn't need to worry about, and you had a whole new set of opportunities that you could actually take hold of and use in the application. And these were kinds of things that you thought, even coming from a Python background, you almost unconsciously just don't think about, because you know how hard that problem is. But with Elixir, things like WebSockets being like super easy, Phoenix channels, first-class citizens in the whole stack, and then having all of that clustered and not worry about which process is publishing to a WebSocket from where, and just being able to trust that it's routed to the right thing is really incredible. So it's, like I said there, the ability to publish via GraphQL to the front end from any Beam node. It's coming from a Python background. It's almost unfair. So thanks to the Phoenix team and Absinthe team and all them for making that possible. It's really, it blows our mind. Similar, related to that, is network control. We've really stopped worrying about processes. Again, Turn is a heavily networked application. So coming from a Python background, long-running network connections were often problematic, and it forced us to make things asynchronous. And so once you're doing things asynchronously, then things like back pressure and rate limiting on APIs become significantly easier, because there's no hard link between both interfaces. Now that you can have long-running processes, and you have fine-grained control over those, implementing things like back pressure and rate limiting on the APIs was just significantly easier to implement and control. Speaking from experience, this was a huge relief, being able to do this like in this fashion. What also worked well is the ability to monitor. We already saw in previous presentations on the ability to introspect all of the processes and the supervision trees and things like that. And so if you're going to run things at scale or at high volume, really invest in your monitoring and your observability of the system. And Elixir makes this super easy. On top of that, there's a whole bunch of really fantastic libraries that build on Phoenix or Plug that really allow you to build hook into tools like Prometheus and Grafana that are immensely valuable and will highlight upcoming problems early on. On top of that, Zipkin for tracing really gives fantastic insight into delays when operating a distributed application, which Turn is. Now, once you've all got that all set up, then it became really easy for us to set up things like PagerDuty to watch queue levels and things like that, and set off automatic escalations when necessary. The next thing that worked very well is automation. If you're running a small team like we were, and still are actually, investing in automation, just invest in automation as much as possible. And the value of a good continuous integration and continuous development setup really just compounds over time. And so automation, it feels like investing in this, it made our team bigger than it actually was. During the growth of the WHO service and the launch and all that stuff, we were still deploying regularly. So production releases still are built and deployed within 3 minutes of a tag commit, and QA releases are built and deployed on each commit. And it just makes deploys much smaller, less stressful as a result as well. And you can start reasoning about things like deploy previews once you have all of this automated. Another thing that made Elixir really easy for us is pattern matching. So identify the things that you can live without ahead of the launch and make it easy to turn them off. So for us in Elasticsearch, with Elixir, it just made it really easy. There were a bunch of functions that exposed a bunch of functionality. We pattern matched on structs, and basically if this flag was on or off, we disabled that feature. And so for launch, we disabled a whole bunch of things. We disabled Elasticsearch indexing, we disabled media support, and we kept everything within the service as stateless as possible. Again, the Elixir made this significantly easier for us. The other thing that worked really well is being able to load test. So load test all the critical paths extensively watch what happens on your Grafana dashboards and make it easy to do so repeatedly. So we load tested the application to 1,800 requests a second maximum. And we were able to, while we were developing, being able to load test and monitor everything, we were able to ensure that our response times remained below 100 milliseconds for any interaction via the API. And we used loader.io to run those load tests. So some things that did not work, and maybe this is a little bit unfair because actually we turned it off with feature flags. So in a way, there's a good side to this as well. Elasticsearch is really, it's a great piece of software, but in our experience, and maybe this is also just our team, it's difficult to run from an operational perspective. And so we are confident we could have done it, but we didn't want to have to focus on that during launch. And so we disabled it for launch. Another thing that didn't work well was half automated things. And those really bite. The longer I'm involved in software, the more I'm convinced that broken gets fixed, but shitty lasts forever. And so some operational things were not automated the way they should have been. And those are completely legitimate reasons as to why. Time constraints, not enough hours in the day, all that stuff. The reality is that we're still trying to address those things 6 months in. So shortcuts taken in production environments are very, very difficult to detangle. Now, I'm convinced that there's no such thing as a squeaky clean production environment. Everything, develops its own set of warts over time. But really just committing to trying at least to make sure that everything's not super messy will really, really help you because everything that is messy is going to last with you much longer than you would like or appreciate. So some of our learnings in this process. So soft launches are vital, and this is kind of an accidental learning. So before we called these soft launches, we said we were going to introduce it to friends and family. Then our first launch ended up with 500,000 subscribers, and we realized that our friends and family group was significantly bigger than we had anticipated. And so if you're doing any kind of launch, make sure you do a soft launch, which means put your system through the paces. See how it performs before before the media is all over it, before it's very public, so that if there are any issues that are worrying you, you still have some time to address them. And so generally we did soft launches 2 days before the publication. This was also the case for the WHO. We had 1 million subscribers before the public launch, and it really does relieve the stress of a big bang launch. And so for every launch since, South Africa, it was 500,000, WHO was 1 million subscribers. Every launch since then, we do a soft launch by default, just because it tests your system and it relieves a bunch of stress. Now we all know when you're from a user experience design perspective, keep things as simple as possible. Now this is also not just a user experience thing, but this is also an application design thing. Simple applications are much, much easier to scale. And so we launched with only a single language, no stateful interactions at all anywhere in the system, no media support, and no search index. Other services launched around the same time or after us, and they were reached significantly smaller, they were at a lower scale than us in terms of messages a second going through the system or a number of uniques interacting with the service. And many of them actually suffered downtime, and they were building a very nice and clever experience, but it was difficult to scale. Ours was very straightforward and extremely simple, but it managed to stay up right at the time when there was almost a global panic around the pandemic. The WHO service was able to offer the updated and relevant information to people around the world in real time, and it was just accessible for everyone. So that's something we're extremely proud of to have been able to do. The other learning is ask for help. We're a small team, and we needed help to pull this off. We couldn't do this alone. So there's a huge amount of credit goes to the team of experts at both Amazon Web Services and WhatsApp, who worked alongside us for what turned out to be the biggest installation of the WhatsApp business API at launch. So practically what that meant, we had multiple WhatsApp groups open, constantly open Zoom calls, and exchanging insights on what were we seeing on the system, how were we seeing it behave. Now, not only that, there's a huge thanks to the Elixir community. When this started, and just remember the short timeline that I was sharing earlier, we sent out an email to a number of smaller teams with the ask to be on standby should help be necessary. And these were teams of people who were authors or involved in technology stacks that we were relying on. And it was really amazing. Everyone showed up within 24 hours, and it was such an encouragement to our team to be able to see that happen. In a time of global crisis, people got together, pulled together, also from the tech community, to launch this important service. And so I'd like to just to take the opportunity to say a huge thank you to Dashbit for the Elixir advice, Sentry for the error reporting tools, ContribSys for Factory, Mike Perham specifically, and Rasa.com for the NLU server that we're using for natural language understanding to power certain features of the WHO experience. Now, this list is significantly longer. We're extremely happy and thankful for the Elixir community for all of the tooling that made this possible. Many of you are contributing this voluntarily or spending time on it, and thank you for doing that. It's made this WHO service launch work. It's made sure that people had the information available to them at a time that was critical, and hopefully only once in a century, if not less. And so we're hopeful that we'll see the end of this pandemic soon. Until then, we're just really thankful for everyone that makes this possible. And yeah, thank you for listening. This was my half an hour. There's a couple of minutes left for questions. If you're interested in this kind of work, I'd really recommend that you join our monthly TurniO town hall meetings, where there's a larger community of social impact organizations discussing chat systems for social good. So that includes the WHO, but there's a really staggeringly large community of organizations trying to do good in the world, and they're in need of engineering help in many, many ways. So thank you. So I'm just looking at the questions now. There's two right there now. The first one, what was the most benefited country with this? It's hard to say who benefited from it the most. There was a significant amount of requests and traffic coming from Arab-speaking countries and India. We know India is already a huge market for WhatsApp. But actually, most of our initial traffic actually came from Arabic-speaking countries. And so I think those definitely, it just showed a need for the service for accurate information that was trusted. So yeah, that was, and then thereafter, it just grew globally. But those were I think the first movers using this service. It was Arab-speaking countries in India. The question is, why did you choose an older version of Postgres? It's the version we've got most experience with, and we knew it could perform. And there was nothing really in the new versions of Postgres that would be a reason for us to switch to it at this point. So it's kind of like, face the problems you know versus facing the problems you don't know in a production environment. I would rather face the problems I know, and so we just stuck with the technologies that we knew. Similarly, the version of Factory we're running is a very, very old version of Factory. There's significantly new and probably better versions of Factory running out there. We just didn't have any experience running in production, and so we were happy just to launch with the older version that we knew. We knew its characteristics, we knew how to handle it, and we were confident that it could scale. So yeah, if there's any other questions, please do feel free to pop them in the chat. And otherwise, thank you. Thank you for listening. I appreciate your time, and enjoy the rest of ElixirConf. And hopefully we'll be able to meet each other again in person at a real conference somewhere around the world when all of this is over. Thank you.